Assalamu alaikum wa rahmatullah. Hi everyone. In this video, we will be working on the first question from the coverage of a grade 11 elite for term 3. So this question includes many suggested questions from AP Classroom. So we will try to work on those questions on a couple of videos. So the first question says a particle starts at time equals 0 and moves along the x-axis so that its position at any time is bigger than or equal to 0 is given by x of t equals t minus 1 cubed times 2t minus 3. Find the velocity of the particle at any time t is bigger than or equal to 0. So to solve part A, we know that the velocity at any time is equal to the derivative of the position. So the position function is given. Notice that we have first and we have second. So to find the velocity, you must use the product rule. What does the product rule say? The product rule says differentiate the first. So there is 3 times t minus 1 squared. I'm differentiating the first times 1. I'm not going to write it. Leave the second, which is 2t minus 3, plus leave the first, which is t minus 1 cube, differentiate the second, which is only 2. Now we can simplify this. I can see that there are 2 terms and they have t minus 1 in common. So what happens if we factor out t minus 1? So if you factor out t minus 1, or we can factor out t minus 1 squared, right? We can factor out t minus 1 squared. If we factor out t minus 1 squared, that leaves us with a 3 bracket 2t minus 3 plus there is only t minus 1 here times 2. So we factored out t minus 1 squared. Now we can distribute here and here as well to simplify further. So v of t is equal to t minus 1 squared bracket 3 times 2t is 6t minus 9 plus 2t minus 2. So one more step. This is t minus 1 squared bracket 6t and 2t, it becomes 8t minus 9 minus 2 is minus 11. This is the simplest form of v of t. This is part A. Well, part B says what? For what value of t? We are looking for the values of t where the velocity is less than 0. We just found the velocity in the previous part. So in this part, part B, you just need to look at this velocity, t minus 1 all squared times 8t minus 11, and you have to find where is this or when is this less than 0, okay? Well, the first one, because it has this power, so this is what? This is always what? This is always positive. The first bracket is always positive. That means 8t minus 11 is less than 0. You add 11 to both sides. 8t is less than 11. Divide by 8. Divide by 8. So t is less than 11 over 8. But it's mentioned in the question that t is bigger than or equal to 0. So we can add it here, bigger than or equal to 0. That would be the answer of the second part. Now moving on to the third part, The third part is find the value of t when the particle is moving and the acceleration is 0. So you have to find the acceleration, and then we need to set it equal to what? To 0. To find the acceleration, we just found v of t in the first part to be t minus 1 squared times 8t minus 11. Okay? So here we have first, here we have second, because we are looking for the acceleration, which is the derivative of the velocity. So we'll apply the product rule. So differentiate the first, which is 2t minus 1 to the power of 1 times 1. Leave the second, plus leave the first, which is t minus 1 squared times the derivative of the second, which is 8. Okay? Similarly, I can see t minus 1 in common, right? T minus 1, we can factor it out. So a of t is equal to what? T minus 1, right? And that leaves us with 2 8t minus 11 plus t minus 1 times 8. So we've got to repeat what we did, right, before, like we will use the distributive property, okay, to get a of t equals what? T minus 1 bracket, this is 16t minus 22 plus 8t minus 8, so a of t as a final answer will be t minus 1, and combine the similar terms here, 16 and 8 is a 24t minus 30. This is the a of t, okay? Now you need to set this equal to 0, okay? You have to set this equal to 0 to find when the acceleration is 0. That could happen at t equals 1, right? Let me just get some space. Let's put this question down. Okay, or at t equals 30 over 24, which is 5 over 4. Now, if you find, the question says find what? Find the velocity or find the value of t, sorry, when the particle is moving, yani the velocity is not equal to 0. So to find v of 1, you will plug 1 into the velocity, which will give you what? 0. Okay? Now you have to find also v of what? 5 over 4, okay, which will be a non-zero value. This is not equal to 0. So the question is asking for what? It's asking for the t value at which the particle is moving, and the velocity is not 0 and the acceleration is 0. This happens at t equals 5 over 4. So this one here is rejected because the velocity is 0. That means the particle is not moving. So this one is accepted. This is the first question. Moving on to the second question. Well, the second question, we have this table of values for t, b of t, v of t. Okay, before we start doing the question, let's agree that v of t, it's the same as p prime of t. Okay, because v is the position and v is the velocity, which is b prime of t. Okay, this table belongs to riding a unicycle back and forth along a straight east-west track. The question says a light is directly above the western end of the track, bend right so that at time t, the distance L of t, so L of t represents the distance between bin and the light, satisfies this equation. At what rate is the distance? At what rate is the distance changing? That means we are looking for L prime of at which t value? At 40. This is what the question is asking for. We have the equation given by the question, L of t squared equals 12 squared plus B of t squared. To find L prime, you need to differentiate this equation, okay, by using which rule? We call it the chain rule. We put the 2 here, so we keep the inner, reduce the power by 1 times the derivative of the inner, L prime of t, equals the derivative of 12 squared is 0, plus again the chain rule. So t, keep the inner, right? Differentiate the inner. Okay? Now we are looking for this business here at t equals 40. How do we do so? We will divide by 2 L of t and divide here by 2 L of t. Okay? We can now cross out this one with this one. Here 2, we can cross it out with 2. So L prime of 40 equals what? B of 40. Now I'm replacing t with 40 times P prime of 40 all over L of 40. B of 40 is given in the table as 9 times B prime of 40 is given in the table as 2.5. This is times, this is point. Now we need L of 40. L of 40 is not given, but we are given what? The equation. So to find L of 40, there is a square here, equals 12 squared plus B of 40 squared. So L of 40 equals square root. I'm taking the square root of both sides of 12 squared plus what is B of 40? B of 40 again, it's in the table, which is 9. 9 squared, this is equal to what? 15. So we will put it back here as 15, and this is equivalent to 3 over 2. L is measured in meters, so meters per second. This is the second question. The answer is 3 over 2 meters per second. In this question, we have 2 particles move along the x-axis, and t is going from 0 to 6. The position of the particle at any time is given by P of t equals, let's just rewrite it. P of t equals 2 cos of pi over 4t. This is how it looks. While the position of particle r, okay, this is for particle P, and for particle r, there is another position equation, which is t, this function t cubed minus 6t squared plus 9t plus 3. So for what value of t, or find all the times t during the given interval, which the 2 particles travel in opposite directions. So we must find where are the 2 particles at rest first, to investigate the sign of the velocity, to know at which interval each particle is moving left and right. So the first step must be differentiating both positions to find the velocity of each. So let's do part A here. It's not part A, sorry, question number 3. Okay, question number 3. What are we doing? We will be differentiating b to get b prime of t, it will be minus 2 sine of pi over 4t times the derivative of the inner, which is pi over 4. And you need to find r prime of t as well, which is 3t squared minus 12t plus 9. Okay, this one can be written as, you can cancel this 2 with this 4. This 4 becomes 2. That means negative pi over 2 sine of pi over 4t. Set it equal to 0 and set r prime equals to what? Equals to 0. Well, if you set the first one equals to 0, you must get t equals 0 and t equals 4. For the second one, you are getting t equals 3 and t equals 1. Now, what's happening here? Our intervals, or interval, goes from 0 to 6. The first particle is having t equals 4, and this one, let me just change its location. Let's put it here. This is 4, this one is 3 and 1. Now, if you check the sign of, for the first line, you will check the sign of p prime of t and the sign of r prime of t on for each of them. So let's say this line for p prime of t and this is for r prime of t. If you check the sign, this one will be negative and then positive. This one will be what? Positive, negative, and then positive. Okay? Now you need to tell for what, find all times t during which the two particles travel in opposite directions. Well, let's look at this interval from 0 to 1. They have different sign, negative and positive. From 1 to 3, they are both negative. Now, from 3 to 4, they are having negative direction, negative signs, negative directions, negative and positive. After 4, they are both positive. So the answer of the answer of question 3 would be t is between 0 and 1, and the second one is 3 to 4. On those two intervals, the two particles travel in opposite direction. So, for question number 4, it says for the same interval from 0 to 6, find all times during which particle r is moving to the right. When particle r, which is the second number line, it's moving to the right here, it is, just a second, it's moving to the right here because it is positive, the velocity is positive, and here as well. So for question number 4, the answer will be from 0 to 1, from 0 to 1, and from 3 to 6. Okay. Question number 5 says, find the acceleration of particle B at t equals 3. Is it speeding up or slowing down or neither? So let's find the acceleration of particle P. To find the acceleration of particle P, what are we going to do? Let's just change this one to 5. Okay, so what are we going to do here in question number 5? We must find b double prime of t, which is the acceleration of particle P. which will be what? So it is going to be negative 2 sine of pi over 4. Okay. So negative, no. This is, sorry. Excuse me just a minute. B w prime of t. So we will use p prime of t and we will differentiate that one. So we have negative pi over 2 as a coefficient. Now what's the derivative of sine? It is cos of pi over 2 t times the derivative of the inner, which is pi over 2. Okay? So this becomes minus pi squared over 4 times cos of pi over 2t. Okay? So after finding what pw prime is, you need to find pw prime of 3. Substituting the 3 into this acceleration, you must get negative 0.74. So this is for what? This is for the acceleration. Now, what is p prime of 3? P prime of 3, is it positive, negative, or what? Look at the number line, the first number line. At 3, somewhere here, okay, p prime of 3 is what? Negative. So this one is what? Negative. And the acceleration is also negative. So are they both negative? Pw prime of 3 is negative, and no, the acceleration should be positive. No, this value is wrong. Sorry, this value Pw prime of 3 is going to be 0.872. And because the acceleration and the velocity have different sign, the particle is what? Slowing down, which means, it's slowing down because they have different sign. The acceleration is negative and the velocity, the acceleration is positive and the velocity is negative. That's why it's slowing down. I will stop here. I don't want the video to be any longer, and we will continue in some other videos. Thank you.